Hi everyone, just wanted to take a minute to talk a little bit about parallelograms and some of their different properties. So we should start out with talking about what exactly a parallelogram is. So a parallelogram, as you can kind of see from these pictures, is a quadrilateral, so it is a polygon with four sides, and it specifically has this property. So if I were to draw a parallelogram, and this tends to be the way people draw them, this side, these two sides, are parallel, and these two sides are parallel. Okay, so it's a quadrilateral with two sets of parallel sides. So that is the definition of a parallelogram. So if you were trying to say, hey, is this a parallelogram? And you saw that it had two sets of parallel sides, then yes, it's going to be a parallelogram. But a number of the other properties that we can get out of this are these. So in a parallelogram, opposite sides are congruent. And really, if we kind of think about the reasoning behind that, right, we know that the distance between parallel sides, between parallel lines is the same, right? So that kind of stands to reason that they're parallel, right? Since they're parallel. Additionally, I forgot to mention this. Parallelogram, a lot of times when you're writing something, you can just use that as a shorthand notation. Obviously, you might not have access to that symbol on a computer. So if you just kind of write like parallelogram or something like that, that's fine. Okay. So opposite sides are congruent. What else do we know? Well, opposite angles are going to be congruent, right? So we know that these are going to be congruent, right? So angle J and angle L are congruent. Angle K and M are also congruent, all right? They're not necessarily congruent to each other. They're just congruent. And that comes again from properties of parallel lines, right? What do we know when we have parallel lines? Well, we know, we have corresponding, we have alternate interior, alternate exterior. There's all kinds of different things that we would have. So, if we had this angle, we would know this one would be supplementary to this, but we also know that this one would be supplementary to this. And when they're supplementary to each other, they'll be congruent, right? So that's why that one's true. It also then stands to reason from that kind of same reasoning of same side interior angles. Consecutive angles are supplementary, right? So this one plus this one is 180. This one plus this one's 180. This one plus this one's 180. Okay? Again, that just comes straight forward from the same side interior. And then finally, kind of in linking with these two, if there's one right angle, there's four. All right? So if a parallelogram has one right angle, it has four right angles. And that just comes, well, from the fact that what do we know about these two? They're supplementary, right? So if this one's 90, clearly this one's 90. And then if this one's 90, clearly this one's 90, and so on all the way around. This is actually going to end up being a specific type, a rectangle, which we'll go into at a later date. But anyway, so now that we have those properties, we can do a couple different things, right? So what do we know? Well, we know if this is 65, this one's also going to be 65, right? That's also going to be 65. And then you could even go further and say, well, if this is 65, what's this going to be? This is going to be 180 minus 65, which would be 115, right? 115. So that would be 115. Similarly, if this was 125, right, this plus this equals 180. Okay. So what's x going to be here? X is going to be 55. So if we kind of go our way around, this would also be 125, and this would be 55. So those are kind of some different things that you could use. The next properties that we're going to look at involving parallelograms comes from their diagonals. So a diagonal, that's just where you're drawing a line from one vertex to the opposite vertex, so that it's not, obviously not a side, right? So there would be two diagonals. The first piece of information is if this is a parallelogram. So if we have it a parallelogram, which again means that the sides are parallel, then the diagonals bisect each other. Well, where does that come from? Just from a quick inspection, without knowing that these are going to be the same, right? Without knowing that this is congruent to this and this is congruent to this, you can probably get the idea that you're going to have to be able to find congruent triangles, right? So you would know that this side is congruent to this side because it's a parallelogram. You could use the angles to get, this measure is congruent to this one, and then you could use that and then angle, angle, side. All right, so that's where that comes from. So diagonals bisect each other in a parallelogram. All right, so this part's congruent to this part's congruent to this part. They're not necessarily the same, right? This length is not necessarily the same as this length, but they bisect each other, which also means what? They have the same midpoint, okay? They will have the same midpoint. All right. The other thing that we know about diagonals of a parallelogram is that they would split the quadrilateral into two congruent triangles. That's a very, very straightforward proof, right? We already know this is congruent to this. We already know this is congruent to this, and that just comes from the fact that it's a parallelogram. We also know that this is congruent to this. Bam. Side, angle, side. All right. This one comes up a little bit less, but it can be very helpful if you're dealing with a proof, right? Because if you have a congruent triangle, you can use CP/CTC. Okay, so let's do a little bit of practice with these. So we have a parallelogram, right? Where SQ, the whole length here, is 42. And I need to find SU. Well, obviously, if this whole thing is 42 and diagonals bisect each other, that would mean that this is 21. Okay? This is 21. Now, this is, again, it's a parallelogram. RS, 19. So that means SP is also 19. Okay, simple enough. Nothing super crazy with the parallelograms. The math behind it, like the algebra work, is really not that intensive. The hardest part will be dealing with proofs relating to parallelograms and dealing with some of the coordinate information. So here I have the coordinates of a parallelogram. So these are the different vertices. So our goal here is to find the midpoint of the diagonals. Or the point of intersection, let me rephrase that. You're trying to find the point of intersection of the diagonals, which we know, based on the fact that diagonals bisect each other, will be the midpoint, okay? So what can we do? Well, first off, we need to kind of just have a decent idea of where everything is, just so we know where to draw. So we have -1, 4. Here's my H. My J is over 3 up 3. K is here. And L is -1, -1. Okay. So why did I bother with that? Well, the reason I really wanted to focus on that just comes to make sure that we knew which sides were sides and what would be a diagonal, right? So obviously these would be the sides of this parallelogram. And the diagonals then would be HK and LJ. So if we check, the midpoints should be the same. And let's just confirm that. So HK has a midpoint of -1 + 3 over 2, 4 - 2 over 2. And it should be at what, 1, 1? Okay, so we have 1, 1. And then LJ, the midpoint here, would be 3 - 1, which is a good start. And then 3 - 1 again. Right? So they would again 2 over 2, 2 over 2, which is 1, 1. Okay. So what did we get out of this? Well, the diagonals, which we just drew in, they have the same midpoint. So that would mean when they intersect, they're bisecting each other. Okay, so that is the point where they cross because they are both on the same line. So you should always have this property when you are dealing with a parallelogram. Now, last thing I want to do in our discussion of what a parallelogram is I would like to do a proof. So proofs do come up all the time in terms of parallelograms. And we are going to spend a whole day or so doing proofs involving parallelograms and proving something's a parallelogram. So this is just one of using the properties of a parallelogram. All right. So first off, let's ask ourselves, what do we know about parallelograms? Well, just from the fact that they are parallelograms comes, we get that sides are parallel, which is helpful. We also know a number of different things, right? We know that, A will be congruent to this angle up here. These two angles will be congruent. Well, no, sides are congruent. There's a lot of information you get from parallelograms. Okay, so let me go through the statements here. Okay, and reasons. All right. So we have parallelogram, and I'm just going to do the shorthand, A, B, C, D, and we also know that A is congruent to E. And that is given. Okay. So let's kind of ask ourselves, what do I need? I need to show that CD and CE are going to be congruent. Well, how could we potentially go about doing that? Well, what do we know about parallelograms? Opposite angles are congruent, right? That does not necessarily give us sides. However, what do we know about parallelograms? Sides are parallel. Okay, so let's just put that down first because we know that sides are parallel. So we know that AD and by continuation AE would be parallel to BC. Now, you're probably asking yourself, why did I go there first? How does that directly help me get a side? Well, it doesn't. It doesn't actually help me get a side directly. And that's just the definition of a parallelogram. Okay, so we have that these are congruent. Now, what else do we have? We're given information about angles. We should use an angle, all right? When you're given an angle, you better be using it somehow. Now, obviously, this is not a parallelogram. This part over here, right? This is a triangle. We have a triangle. However, we need the sides to be congruent. How do you show that sides of a triangle are congruent? Well, if you have that their two angles down here are congruent, you can get that to work. So I have to somehow say that A and D are congruent. Okay, there's a couple ways I can go about doing this, and I'm going to take this route. So I know from the parallelograms, right, the theorems about parallelograms, I know A is congruent to this angle up here. So I'm just going to write that down. Angle A is congruent to angle B, C, D. And I'm just going to, okay, so that angle. And that is opposite angles of a parallelogram are congruent. The angle, yeah. That's a theorem, right? Okay, well, how did that help me? Well, I know that these two are congruent. And I know that these are parallel. So this is a transversal. So what do I know about this angle and this angle? They're alternate interior. Okay. So that would mean angle BCD is congruent to angle CDE. Okay. And why is that true? Those are alternate interior angles. Now I am going to be explicit, and I am going to say that by the transitive property, we know that this angle is congruent to angle E. Now I have that two angles are congruent, so that would make the two sides also congruent. So I have succeeded in doing what it was I needed to do. And that's the converse of the isosceles triangle theorem, okay? Now, the big thing that we need to be careful with these is we bring in a lot of old concepts. We bring in triangles, right? We know that we can have congruent triangles. We're bringing in parallel lines. We know alternate interior angles are congruent. Same side interior angles are going to be same side interior would be supplementary. You know, we're using the isosceles triangles. All right, there's a lot of different pieces that come together to make these parallelogram proofs feasible, okay? So we're going to take our time with these. We are going to spend the rest of the week doing parallelogram proofs. So do your best, and we will get through this together, all right? Have a great day.